Hi, my name is Sophia Colosi, and this is my presentation for Lab 2, which involves the motion of a falling object. What we are going to do in this lab is apply our knowledge of Newton's second law stated below to observe a falling object. We will also consider drag and how that affects the object's motion. I'll talk more about this later. For the first part of the experiment, I recorded a video of myself dropping a tissue box and used Tracker to extract data, which you can see on the right. This will be our observed data. Next, I coded the predicted model of a falling object that exclusively includes the effects of gravity. On line 33, I changed the mass to the mass of my tissue box in kilograms. I initialized the position, velocity, and time to 0, and then on line 46, we assigned the value 9.8 to g, which will be the variable I use for gravity. Because this model doesn't include drag, I left my value for b at 0 and rewrote the equation for my net force on line 64, which is essentially just weight. On lines 68 and 70, I applied Newton's second law, and then on lines 83 through 87, I just changed the appearance of the force arrows for the model. This is what the model looks like after running my code. In my second model, which includes both the predicted effects of gravity and drag, I had to change up my code a little bit. On line 65, I defined the weight force, and on line 66, I defined the drag force. On line 67, I added the weight and drag forces to get my net force. On line 52, you can see that I assigned a value to my variable b. I got this value by essentially guess and checking until my predicted final position was similar to my observed final position. I also changed the arrows, and this is what the model looked like after running. After completing my models, I compiled my data in Excel and put all three sets of data onto one graph. The blue line represents my observed motion, the orange line represents the predicted motion not including drag, and the gray line is the predicted motion including drag. As you can see, the predicted motion with drag is more similar to my observed motion than without drag, but my data honestly doesn't look great. In this scenario, we would expect that the predicted motion with drag and my observed motion would be much more similar than my data reflects. This could be due to a few reasons. I could have traced the center of mass of my object in Tracker inaccurately, or my tissue box could have been too heavy to effectively see drag in the allotted time. These are just a few examples. None of these models predict a terminal velocity now, but eventually, if I had more data, the observed motion and predicted motion with drag models would predict a terminal velocity. They both include a drag force that will increase the faster the ball goes, and eventually the tissue box would reach equilibrium, or terminal speed. The graph below does not accurately represent my data. It just shows a velocity versus time graph of an object that reaches terminal velocity to give you an idea of what we're looking at. Now, let's say that I threw my tissue box downward instead of just dropping it. Would the terminal velocity be the same? The answer is yes. Terminal velocity occurs because eventually the drag force will equal the gravitational force on the object, and the net force will become 0. If you throw the object, it might reach terminal velocity sooner, but the terminal velocity itself would not change. Thanks for watching.